So let me start recording first. Okay. I will make detailed announcements today about next week's presentation and also the final reports for your projects, what I expect from you. So from the project reports, actually, I can start at the beginning and also at the end about these things. So presentations next week, the schedule is already posted. So these are from last year's slides. So certain things are updated here. Next week, we are going to have 5-minute presentations per group, okay, as per schedule. It may, I mean, you have to start attending at the beginning because it's not the exact time. If you look at the schedule that I posted here, your starting time can be like 10-15 minutes early or late depending on how the so presentation schedule, it's right here, depending on the delays we may have. So it's 5-minute slots per group, per project, but delays may happen. Some presentations may finish early. So do not expect to have your presentation exactly at that time. Just follow the order of presentations, and so therefore you have to attend the meeting at the start of the meeting at 7. Okay, and we will go all the way until 9 for about 2 hours. All right, a little bit more than 2 hours. So we will have a 10-minute break in between. So we're just going to follow this order, and I expect 5-minute presentations. Here in the presentations, any group member, if it's a group project, any group member may make the presentation. It's okay if all group members are not present during the presentation. I expect you to just talk about your project idea, your current progress, and what you plan to do. You maybe if you have built a prototype already, you may show us a snapshot of the prototype. And in a 5-minute presentation, I mean, all you can do is this. I mean, just describe what the project is about, what you have accomplished so far, and what you plan to do until you write your final report. How many users are you going to test this interface on, and how many alternatives you plan to build? What are the differences between alternative user interfaces that you plan to build and prototype? Things like that. Any questions about the presentation content? I'm not expecting you to show a finished project because these are not final. The final report is going to be due another 3 weeks from the presentation. So you will still have time to work on your project to finish it before the final report. And the project, really, the main focus on the project is not to build just an application. It's the main purposes, or just to build some prototype that cannot be used. The main purpose is to have a usable prototype that you can use to evaluate its usability by using real users. So the main component of the project final reports is this evaluation results. Okay, for example, I expect everyone to use predictive evaluation, not predictive evaluation, interpretive evaluation, in which real users are employed, because you cannot, we are not human-computer interaction experts to use predictive evaluation. We don't have accurate models for users. So most of the projects, I expect the interpretive evaluation to be used, which employs real users. And what type of feedback? For example, did you redesign? Did you make modifications on the user interface after these user tests, user evaluation? How many users did you use? What were the results in terms of usability? What were your usability goals? And what did the evaluation showed? So the main focus of the project is to have some usability test on an interface, and which is an important part of user-centric design. All right, so this part, a description of a short description of your prototype, what you have completed, what types of prototypes you have built, what are the different alternative design decisions you have taken. So this is the first part. And this part, which design guidelines did you apply? Or you may talk about your usability goals here, not only design guidelines, but you don't need to be too detailed about these things. You don't. I don't want you to repeat the generic things here for your project. I mean, just uh, what was the focus of your project in terms of the usability goals? Do you want it to be easy to be used, easy to be remembered, applicable to a general audience or a focused group of users? So what was the usability goals for your specific application? You should describe it here. And as I said, the main component of the report will be this evaluation results part. So this is the main part, which you don't need to have a finished interface. It may be a vertical prototype or a horizontal prototype, but you have to have a way to have real users somehow use your system to a certain extent and give some evaluation result. Not only in terms of questionnaires or surveys, but did you collect any numerical quantitative values about those usability measures that you were trying to assess about your project? So this is basically the final project report, and your project is mainly graded by your final project report, because everybody got very good grades from the project proposal, and I'm not going to give grades from your final project presentations. The presentations next week, its main purpose is to just have share your different project ideas with everybody in the class, and maybe get some feedback mid project feedback about your projects. Okay. Also, if it's a group project, there should be a section about how you divided the tasks of the project into among the group members. You should have a section if it's a group project. All right. So this is what I expect from the final project reports. And today I'm going to just spend 1 hour of your time. I will finish these slides in 1 hour before the quiz starts at 8. And after the quiz, we are not going to have our second hour of class, so we are going to finish everything in 1 hour. And there's no more readings or quizzes after today's quiz. For next week, it's only the final project, not final, the project presentations. And also about this, as I announced on OptiClass, we have an assignment for project presentations. You have to send me your project presentation by Thursday night. So I'm going to maintain all of them here on my screen. I will do the screen sharing. All you need to do is unmute yourself to do your presentation. You don't need to switch to your computer. You don't need to even have a computer. Just you can even connect from your cell phone and unmute yourself at the time of the presentation. I will switch the slides. I will basically open your presentation when your turn comes, and as you make your presentation, I will go over I will switch the slides, and it will be on my screen. That's why I need all of the project presentation by Thursday night. All right, I will arrange them in an order and put them in a folder, and we'll go one by one over them. And today we are going to have our final quiz, which will be available exactly at 8 p.m. sharp, about 48 minutes from now, and this will be the last quiz. And in terms of the schedule, we are currently week 13, and next week final presentation, project presentation, and we are going to have if you want to read this, there's optional reading about what human-computer interaction means, and this is a report. A very long report about human-computer interaction these years. Okay, so tangible interfaces, for example, wearable computing, smartphones replacing these old phones, simple robots, robotics, for example, things like that. And this may be an interesting need. And if you remember these things, Apple actually, the iTag is, for example, are things that make different objects being connected or being able to form. So there are different ways of interaction will be possible. So you may actually may want to read this optional article if you want. It's a very long article, but it may be interesting if you wonder about what the future holds for us in terms of human-computer interaction. Okay, so let's go ahead and start about this week's slides. If you have any question, feel free to write in the chat box or unmute yourself. Okay, ubiquitous computing. I mean, this term is not used anymore. I mean, it was very hot in maybe 1980s when personal computers came about, and in maybe in 1990s. But this term today is replaced with the term IoT, Internet of Things. But Internet of Things the focus in Internet of Things is not on the user interface. It's not about usability. It's about devices around us connected to a global network around them, talking with each other. But in Internet of Things, the user probably is not that much in the focus. But in ubiquitous computing, it was really about interacting with our environment and having embedded computing devices which are really small and not visible. So ubiquitous means not visible but everywhere. Today in today's slides, I'm going to talk about some introduction to ubiquitous computing, the history of it, and the challenges and requirements. And many challenges and requirements still hold for Internet of Things, the IoT. So it will be relevant to today's topics as well. So what is ubiquitous computing? It is the method of enhancing computing use by making many devices or services available throughout the physical environment. So we have examples of that today. For example, speakers being available for connection by your smartphone, or other gadgets that are around at homes. For example, we can use our smartphone as a remote controller for the TV. The TV may be connected to the internet, it may be connected to your tablet. So all these different services, like printing services, being available, and if you make those computing services available around the physical environment, and they become invisible, they are embedded in your physical environment, we call this basically ubiquitous computing. But here, Mark Weiser can be considered as the father of ubiquitous computing. He was a researcher in Palo Alto Research Center, Xerox PARC, and they developed many projects that were really visionary at that time. Even in 1980s, they developed really nice, interesting user interface projects. Okay, so the important thing here is that the technology shouldn't be in our focus. It should be embedded in the background, making it invisible to the user. It should enhance our interaction with technology, but it should not be the main focus. The tasks should be in focus. For example, if your goal is to use your phone as the remote controller, it should be really easy to do that. I mean, if you take a lot of time to connect your phone to the TV, and the main task becomes making it the remote controller other than using it as the remote controller, then it's not good. It should be the way we use the technology, the function for our purpose should be really invisible. So and profound technologies, there's actually a saying for that. Profound technologies are technologies that disappear in our lives. And smartphones are like that, actually. I mean, they're really so embedded in our lives, we don't even think about them in our focus. The main task become the focus. So ubiquitous, its dictionary meaning is it means present everywhere, simultaneously encountered in numerous different instances. And here, it's making computing resources available to all devices around us. And users should not get lost in the way. That's the main thing. I mean, because they should make our lives easier without our particular attention. Here in Palo Alto Research Center in Xerox PARC, they tried to define certain things like universal computing environment that hides computing instruments, devices, resources, and technology from applications or customers, they become invisible to the users. So it was, I think, all these ideas, they may seem old, but they are really the seminal ideas that basically gave birth to ideas of the Internet of Things. And IoT is possible because we have all these smaller sensors, the networks. For example, without the Bluetooth protocol, things would be difficult to connect, or without wireless connections, or without 5G networks. So all these things are requiring more resources, more bandwidth, and providing the networking technology to provide these things help all these computing instruments connected to each other and become invisible. So ubiquitous computing is computing everywhere. Physical devices around us, not just our smartphones and computers, but other things that are also computable, that have computing power, like your cars, your home appliances, or even your office desk or your projector. Whatever technological thing you can think about. For example, the walls in your home, maybe a large display, for example, that you can use to do different things, to work or to watch movies. So the idea is to have many embedded, variable, handheld devices that communicate transparently to provide different services to the users. We're going to see some example applications, what kind of services they can be, but it's really based what the user needs, and the technology provides all these different functions to us, and it's bound by it's limited by our imagination, basically. These different services, what you can do with them. And here, the important thing is we want all these devices to be connected to each other. One of the biggest challenges, even to this day, is power. Okay, so many homes, the main challenge is to have all these cables. So wireless electricity is not that feasible yet. You can have proximity charging, but still you have to have lots of cables lying around. And if you have all these different sensors that are embedded in the environment, or different devices that are embedded in the environment, you have to think about what kind of power they're going to consume and how are you going to connect them to the grid. And there's also short-range wireless communication capabilities. That's basically describing Bluetooth. And the devices utilize multiple onboard sensors to gather information about surrounding environments. So these are all things that are realized today. Context awareness. This is, again, still a research challenge. How these devices know where they are, if they are fixed in a static environment, or they can move with you. For example, certain devices, they are fixed in home, but some of the devices you can move them along with you, like a speaker. For example, a speaker, when it's indoors, can it understand that it's indoors? And so that when you take a speaker outdoors, it automatically adjusts its volume to become louder, things like that. And most of the devices, we still don't have this context awareness. Improvised dynamic interaction among applications that are based on specific contexts. Sorry, these 2 weeks I'm also engaged in informatics Olympiads internationally. So today it was European Girls Olympiad in informatics, and International Olympiads in informatics is starting tomorrow. So we are also people are chatting about setting up their computers. The competition is going to be held online, so that's why we have these. Let me actually just exit from Element here. Close window, but I think it will still pop these interface and the notifications anyway. Sorry about that. So the goal of ubiquitous computing is to make life of users easier. As I said, the technology itself shouldn't be in the focus. It should be a guide. It should be a helper, an assistant. We want to make our life invisibly better assisted by computers. That's the goal of ubiquitous computing. So here I'm going to now talk about a little bit about the history of ubiquitous computing and who Mark Weiser was, and some projects that they developed at Xerox Palo Alto Research Center, which were some of them were really inspirational to technologies we use these days. For example, some technology they had. So Mark Weiser was the head of Xerox Palo Alto Research Center, I think, or he was a researcher there for 10 years between 1991 and 2000. And these are some of the technologies, and he passed away in 1999. So he was a researcher at Palo Alto Research Center, and he first articulated the idea of ubiquitous computing in 1988. And he has called ubiquitous computing as highest ideal is to make a computer so embedded, so fitting, so natural in its environment that we use it without even thinking about it. So it becomes an extension, a natural extension of human cognition. Okay, and I think I always state this. Smartphones are like this. Smartphones, the applications on smartphones are so natural these days, and we are so used to them. For example, to communicate with a group of people on WhatsApp, you don't need to talk about the application. You just take a look at your notifications, you start typing, you speak. So it's really, it becomes a way to socially be active in online, and you don't even think about the functions, different functions or settings that WhatsApp provides you. You just use it as it's something, a natural way of communication. So in one of his talks, Mark Weiser outlined a set of principles describing ubiquitous computing. So one of those was the purpose of computers is to help you to do something else. Especially in 1988 or so, using computers, you have to be trained a lot. It wasn't available for everybody. So you have to be, using the computer was the main task maybe those days. But he envisioned that the computer is there for you to do something else. For example, write a document, watch a movie, converse with your friends. So it's not the purpose is not using the computer. The purpose is to do something else. And the best computer is a quiet, invisible servant that helps you establish those goals without requiring your attention. So the computer, as I said, should extend our unconscious. It should be a natural extension of our cognition. And this is what they call the calm technology, designing calm technology, the technology that informs us but doesn't demand our explicit focus or attention. So as I said, it's a natural extension of our intellect and helps us focus on tasks. So Palo Alto Research Center in 1990s, 41 people immersed in ubiquitous computing environment, in which they they designed different interfaces, they experimented with different things. They had notepads similar to the iPads we use today. They had wall screen displays, blackboards, electronic scrap papers. So they experimented with tangible interfaces, large wall-size displays, notepads, and then different from a standard PC is that when you have these devices embedded in your environment, in your office, you cease to see them as computers anymore, and they become the devices that you use to conduct your actual tasks. One of those projects that they worked on was named Active Badge. It was before cell phones were that popular. It was a smart telephone network, this Active Badge. It was when you're in a large company and you have meetings in different rooms, you may not be in your office all the time. So it was kind of a tracker which automatically routed your calls to the correct place in the building. If you're meeting somewhere, it knew that you were really there. So there are some privacy issues here too, but the main purpose was with your badge, which was active. It told you the whole building knew where everyone is. So with the active badge, it was available, and this technology is available these days very well. I mean, this is an easy technology these days. But with just this simple idea, it opened up a whole new area of research and helped realize a new opportunity for context-based computing, uh, doing different things depending on the current situation, depending on where you are. And the Calm technology, I talked about this, so I'm going to skip these parts. Ubiquitous, one person computing, one person in an environment, and many computers that share this person, helping this person. That was the vision in those days. They one other projects they did was in Xerox PALT Research Center. They had tabs, pads, boards, applications. And these are the names of the projects that they worked on. This is a tab which has some buttons here. It is a monochrome touch screen. And remember, this was way before we had tablets or smartphones. So this was a tablet like this. Was really revolutionary those days. It was a prototype handheld computer. The good thing is that for certain things, it actually is better than today's tablets, like a 2 week battery life. Who has a 2 week battery life on a tablet these days? It's just my children are charging their iPads twice every day if they're using them a lot, for example. Its processor was very low power, but it uses an infrared base station into the ceiling for network connectivity. So the Wi-Fi also was not that popular those days, but they had a way to do Wi-Fi by using infrared. That was one of this project was considered by many to be the most significant of the prototyping efforts. This is another one. This is the pad. Maybe you may consider this as the father of iPads or tablets. As you can see, the margins are too large, but everything was large those days. So certain applications run here. I think multiple windows may be open at the same time. You can interact. The touch screen technology was not that developed those days. Therefore, you were able to interact with a light pen like this. And this is the board application. So a large screen display in which you can conduct conference calls with a whiteboard. So this looks very much like the Zoom meetings we have today, but in a company where you have walls in different places, you can just call and have a meeting with somebody else immediately. And I'm going to talk about challenges and requirements next. Or maybe we can even finish early today before 8 p.m. and I will have the quiz, or maybe I will just leave the quiz at 8 because maybe some of you may not attend the class at time and may think that it's 8 p.m. and they may miss the quiz. So I will just maybe leave it on for until 8:10. But let's see, we may be able to finish these slides earlier than I think. So here, there are many of these challenges and requirements are still they still hold today about the ubiquitous computing. But in terms of scalability, we have many devices that can connect to networks. They are smaller and smaller. The sensors are available, low power. Networking is really common these days. So there are different challenges from different aspects. There's the privacy and security issue that we need to talk about. Resource discovery. How do you, when you get into a room, how do you know which services are available to you in that room? Whether there's a projector that you can connect wirelessly, or whether there's a speaker you can connect wirelessly. So how do you discover the resources that are available to you in your current environment, especially when everything is dynamic? This is a challenge. How do these different things interoperate? If they use different protocols, different applications. For example, we still have the domains of different, I mean, Android and iOS, for example, they are two different domains. I don't know whether they're very interoperable. Usually when you have an application, maybe the developers write different protocols for iOS and Android separately, which will make the software larger than it should be. So interoperability is definitely an issue. I remember, for example, a couple of years ago, our smart TV allowed connection from screen sharing from an Android phone, but it wasn't able to do that from an iPhone. So, which means that there is a service right there, a large screen available in our living room, but only it operates with certain type of operating system. There's issues of reliability, mobility, and networking is really developing well these days, especially with these wide area networks or 5G networks. The technology is in really good pace developing into something that is usable. And user interfaces, we have speech recognition is getting better and better, so we can use speech to interact with these objects as well. And nanotechnology is definitely needed as these devices get smaller and smaller and smaller, and a lot of them are going to be embedded in our environment. So if you want to make them smaller, you need to get into the domain of nanotechnology. And there are different technologies that nanotechnology is related with. Sensors are getting smaller and smaller. So this was a sensor which is twice as large as a penny, but it has a light sensor and temperature sensor on it. It has a 20-meter range. There is this research area called sensor networks. When all these things are distributed in a large environment, these sensors, how do you make them communicate with each other or communicating with hubs, sandbag information, things like that. So this is also another temperature sensor. And display technologies, the LEDs, light emitting polymers, that are flexible. So we have organic LEDs, for example, OLED screens, which are actually they can be curved or flexible displays that we can use in everyday life. There are many applications of ubiquitous computing, but this is an important feature of ubiquitous computing. All those devices being aware of their context, where they are. Usually the resource discovery these days are done by first coupling a device with your smartphone or something, which is called pairing. So without pairing devices with each other, the resource discovery cannot be done automatically from the context. So that's one thing that people solved this challenge these days by introducing this concept of pairing a device with something. So they have to have a tether to be attached to so that they're usable. But the original ubiquitous computing, the idea was they shouldn't be paired before being used. The pairing should be done automatically, or when you take them to some place else, they should again understand what the context is and discover the resources that are around them in an easy manner. So let me skip this. So I talked about networking. Networking technology is really developing well. Mobility is as you move things around. Even in your home, when you go from one place to another, one room to another room, the wireless connectivity may get worse, for example. So the problem of this connectivity is a major problem when you think about mobility. So this mobility is an inherent property of ubiquitous computing. So how do you provide continuous connection for those devices is a challenge, a networking challenge. And there are, in an ubiquitous computing environment, there may be thousands of computing devices, sensors that are around you. Think about the whole smart home system where there are different sensors in different rooms. There has to be something that controls them. But if you have more and more of those small devices embedded in your environment, scalability at some point will become an issue. and how all these autonomous devices connect to a centralized system or operate independently. This is a challenge that needs to be addressed as well. The issue of reliability is uh, whether the service is available all the time to us. These systems, for example, if you have those sensors that are lying around, they have to self-monitor themselves, whether they're off or on. If there's something wrong in their hardware or in their software, they need to be able to monitor this. They have to regulate themselves automatically. And they should have some self-healing features, like in biology. Uh, this will help the reliability of those computing devices that are embedded in the environment. So I talked about interoperability. I actually talk about all these items one by one. I talked about resource discovery too. Privacy and security. And when we are in a fully networked world with ubiquitous sensory equipped devices, there are several privacy and security issues that we need to consider. And some people will be worried. It's like a Big Brother type of George Orwell's 1984 type of environment in which privacy, there's a potential of total monitoring if this gets into hands of some bad people, evil people. What they will do with this data may worry the users, and that's understandable. Yeah, and I'm going to show you some ubiquitous computing examples, some devices that have some computing capabilities. There was a company, I think this company, I don't know whether it's bankrupt or not, but this was from my old slides. Let me search for ambient devices. I think they may still have some devices, but the idea is what kind of physical objects in your home do you want to give some computing power to? Imagine, for example, an umbrella, which is always connected to the internet and subscribe to AccuWeather service. There may be they may register to certain feeds like this, and they may web services like AccuWeather may provide these for these devices. Imagine your umbrella at home is connected to the AccuWeather service automatically. And when you're about to go outside, it tells that, oh, okay, today there's a chance of 50% chance of rain. Please don't forget to take me. So that's an example of a physical object that has computing power, is connected to web, knows whether it's going to rain or not, and ask you to take it with you. All right, so ambient devices was the idea of this company. Wow, on an IKEA lamp, running Doom on an IKEA lamp a few days ago. So that's really interesting. So they use it as a monitor. You mean screen? IKEA lamp. So how did they? So probably an IKEA lamp. Wow. So probably it's just like those bendable displays. Maybe this IKEA lamp has this. Oh, so it was running Doom. So, oh, I see. It wasn't displaying, so it was. Do you mean the Doom game, right? The PC game Doom. So, wow, nice. So yeah, you may use it as the lamp was not a display device, but by running you mean it had some computational power, and it was without displaying. What was the display then? So there should be some display. It was not the IKEA lamp itself that was the display, but it was running the Doom game on it. So yeah, that lamp really has some computational power. Interesting. So yeah, what kind of other physical objects, you want some computational power in them. So these ambient devices, they may use some small additional display. Okay, I see. But yeah, interesting. So with all these small computing powers like Raspberry Pi available to you, different sensors available to you, gyroscopes, light sensors, you can actually build some of these prototypes at your home. These physical devices having some, I mean, physical objects having some computational power. And the idea of this ambient devices, ambient orb was, for example, a desk side lamp, desktop lamp uh, that changes color. And with the LEDs, for example, that can get different colors, it will be easy to build such an ambient orb yourself. Imagine, I just recently bought, I didn't know these um, household lamps. Now you can buy one household lamp which may be connected to your network wirelessly by like 70 Turkish liras, 60, 70 Turkish liras. You can get a good one, even 30 liras, they're available. What happens is that these regular uh, lamps, they have, no, they're not regular, they are LED, they are LED lights, LED, and they also have some networking capabilities. So when you connect them to your wireless network at home, then you can use your phone. Uh, so you can turn those lights to smart lights, and you can control them from your phone. And they, for example, they can change color based on the music playing on your phone. You may turn your room into a disco, or you may get different color lighting. Imagine if you can do that, if you can send some command to that lamp based on some user input. You can also do that by writing a program, for example, changing your lamp's color based on the stock share that you have recently purchased. When it gets, for example, when it loses its value, your room gets red, for example, tells you to sell it or to get rid of it. Or if the stock shares increase, it turns into greenish color. So it will not be very difficult to write a program to send these commands to that lamp so that it's connected to the color of the lamp is connected to some information that you are monitoring. Okay, it may be connected to a football game. If you're ahead, it will turn green. If you're losing, it will turn red. Things like that. So this is what ambient orb was like. Actually, it was a lamp like that. So Doa, share the YouTube link. I'm just going to put it here, and actually I can share with this everyone if you can, if sound is required. Oh yeah, this is the one that Utku was talking about. Kia Smart Light
Reported
Bulb.
today, 93 classic shooter to run on virtually anything that has a microprocessor. The latest absurd entry,
Nice.
an IKEA Traud Free GU10 candidate, or a TIC.
So this is just an image of that one, but yeah, it's nice. Yeah, hackers get Doom running on IKEA smart bulb. So yeah, when we have these smart bulbs, any microprocessor power or any connectivity, you can turn them to anything you like. And yeah, as I said, these lamps that you can buy only very cheaply, 50 liras, 70 liras. Uh, you may just write programs, so they also become like some information display devices with these color coded things. They may alert you to certain things. Okay, if your meeting is in 10 minutes, it may turn red. So it may actually you may connect them to your Google Calendar, and based on if you have a meeting or if your classes start, especially with these coronavirus, everybody was at home at night. Probably you're currently at home, for example, but you don't want to miss the 7 p.m. lecture. But if you start watching TV, you may forget that it's starting at 7. But what happens if 5 minutes before 7, your room light gets redder or blinking, saying that, oh, you have a class now? Okay, we may even teach them Morse code. I mean, we can have them blink in Morse code. If you know Morse code, it's not just color coding. You may actually communicate with those devices with with Morse code. So that was the idea of ambient orb. Let me search for ambient devices. Ambient or ambient orb. It's this one. This is the image. So they still have a running website. I don't know whether it's sold or not, maybe in Amazon. So they have an alarm clock. This was the ambient orb. Basically, it was a LED lamp which was connected to the internet and subscribed to certain real-time feeds, stock market. You can tie it to a stock market share, traffic congestion in on the route from your home to your office, for example, pollen, if you have allergies, pollen forecasts, or any ambient information channel, weather, wind speed, and other things. Okay? So, and so the last thing here is mobile interface design guidelines on my slides, but it has, if you have these embedded devices, these days really the most embedded things we have, I mean, the computing power that we use regularly is our smartphones. But with the networking technologies, Bluetooth, Wi-Fi being available, I mean, we can have these LED displays become all around your house. You may turn your house with these different color lamps. It may be color, that's one output channel. It may be sound. We can also have smart speakers that will that will maybe display some audio or some speech output based on what's currently going on. Okay, so speakers can be connected to the internet easily. So the only thing that remains is to write programs that make them context aware and that make them easier to use. The technology is here. The only thing that is missing are the applications that use these technology effectively. So I think you may have, with some companies with nice, interesting ideas, they may turn the needs of people, the functions that people want to perform, I mean, the tasks that they want to perform. If that device is going to make our life easier, then why not apply that? If you're interested in how different design guidelines for smart devices, mobile phones, for example, you can take a look at these websites. And this is it basically. I already mentioned about the presentations next week. It's going to be, if you missed at the beginning of this class, it's going to be 5 minutes per group. These are not final finished projects. You don't need to show any demo. Just show your current progress of your project, what your project is about, and your current progress, what kind of prototypes have you built or you plan to build, what kind of alternatives are you going to test, what are your usability goals, what is your target user groups. If you talk about these things, it will take 5 minutes anyway. So, you will have a chance to get feedback from your classmates and from me on your current progress. And final project reports are going to be due on Sunday, July 11th or 12th. I think July 11th is Sunday, so it will be July 11th. 11th of July, Sunday, will be the deadline for your final project reports, and I will have about a week to regrade them. And the main component of the final project report is the main part is the evaluation results, where you present their usability tests, their outputs, interpret your usability test results, and what kind of usability goals you had in mind, how did you test them, what did the test say, based on the test results, did you design another alternative that improves the original interface, things like that. And that's it. Okay, so I will see you Wow, so this is again the original write-up Utku shared with us about this Doom, playing Doom on an IKEA thread-free lamp. So this was a, let's see what kind of a lamp it is, what processing power it has. Yeah, it's this one. Smart lighting. So yeah, as I said, IKEA also jumped into this lighting, smart lighting idea, and you can buy these things. Yeah, so this one, for example, I have something like this at home, like for 70 liras. And since it's LED, you can have different colors. You can control it from your smartphone. So yeah, wireless LED bulbs, steering devices, accessories, smart integrated lighting. So this is that one. Which one is that? Thread free. So this one, oh, it's also it's about like $12. Oh, okay, so this also seems like a regular light bulb. Maybe they may have run Doom on this float. It looks more like a computer screen. So if it can display a LED colors, different things. So oh, there's also this thread free. This is the remote control of that. Oh, this is the remote control for your lights. Okay, so we can jump on that wagon as well about smart lighting. All right, but yeah, as I said, there may be smart speakers, smart lights, whatever you think about the providing an output and connect it to to your home. Again, when I talk about these smart lights, the first thing you have to do is this one, pair it with your home wireless or with your smartphone. After you pair it with your smartphone, then you can control it from your phone. Or you first need to have a way to instruct it to connect to your wireless network at home. And in order to do that, there has to be you cannot avoid actually this pairing step because of security issues. All the Wi-Fi's at homes, they have passwords to connect to. So the light will not going to know your password automatically. So you have to do this initial step of pairing to be able to use them. But after you pair them, it's really easy to use all of them. All right, so that's it. We will have our quiz in 4 minutes. Don't forget to attend the quiz in 4 minutes, quiz 8. It will start at 8 p.m. sharply. And after you finish your quiz, that's it. We're not going to have our second hour today. That's it. And I will see you all next week at 7 p.m. For the presentations. All right. Take care, everyone. Have a nice weekend. I will stop recording now.